5A part 1 of the question asks about how chemists could use GC to predict the number of esters in the mixture, and to do this they would have to use the number of peaks from retention time and looking at the areas. You'd have to say both the points to get the whole mark. The second part asks why there would be an uncertainty about using GC alone to predict the number of esters in the mixture, and that's basically because many of them could have the same retention time. If two esters have the same retention time, it's hard to decide which one could be which. The second part of the question basically asks you to identify the ester using the proton NMR spectrum. This ester has an MR of 164, so we'll have to keep that in mind. The first peak at around 2.2 ppm shows a CH3 bonded to a C double bond O. This is because of its integration trace of 3, and because of it being a singlet, it could be on the end or could be in the middle, but because of this it is adjacent to no non-equivalent hydrogens. The second peak at around 2.7 shows a CH2 bonded to a benzene ring. This is because, again, of its integration trace of 2, and because of its triplet peak, it should be adjacent to another CH2 molecule because of the n+1 rule, where it should have two adjacent non-equivalent hydrogens next to it. And it should be adjacent to this molecule from peak 4.4, which shows a CH2 bonded to an oxygen because of its integration trace of 2. And because it's a triplet, it will be adjacent to this CH2 here. So at the moment we have a benzene ring bonded to a CH2 next to another CH2 next to the oxygen. And the last peak just basically shows that there is a benzene ring and that it has only 5 hydrogens on it. And the other carbon is attached to this CH2 here. So the last bit of the molecule, which is the CH3, which we said should be in the middle or on the end, should be on the end. So this oxygen should be attached to the carbon, which has double bond oxygen, and on the end is the CH3. And that's basically the end molecule that you should get, which is the ester that they're asking for. And to check that it is, you could just match it to the 164 MR, which it should. After labelling the diagram, as you see, you should start writing the answer in paragraphs from talking about each of the peaks first. So the first peak at 2.2 ppm shows the CH3 bonded to the C double bond O. And basically you should say that because it's a singlet, it's adjacent to no non-equivalent hydrogens. So that's the end part of the molecule that we found. Then we'd go on to the second peak, which was at 2.7 ppm. Shows a benzene ring attached to the CH2 because of its integration trace of 2, which shows that there is 2 hydrogens on there. And again, because it's a triplet, means it should be adjacent to two non-equivalent hydrogens. And as we said, this would be the third peak. and the third peak at 4.3 ppm. Shows a CH2 bonded to an oxygen and is adjacent to two non-equivalent hydrogens. And this would be the second peak that we found. So the end part of that one we had was the benzene ring bonded to the CH2, which was the second peak, and that was bonded to the third peak, which was CH2 bonded to an oxygen. And then the last peak, .3 ppm, shows the benzene ring with only 5 hydrogens on it because of its integration trace of 5. So I'm just going to draw the end molecule again, right at the end. So this was the first peak. This was the second peak. This was basically the third, where it's attached to the hydrogen. The carbon, sorry. And then the last peak was the hydrogen on the benzene ring. Then you'd have to make a direct link to the MR to get the last mark.